Hi everyone, I am Vincent. Welcome to this Chem School tutorial. This is my first presentation on writing chemical formulas. I am really excited to make this video on how to write correct chemical formulas. We shall learn how to write ions and free radicals correctly, then determine their valency before we write the chemical formulas. The table below shows name, symbol, and valency of some ions we shall encounter. But first of all, what is valency? Valency is the number of electrons an atom loses or gains. Take a keen look at some of the ions. Again, the next shows the name, symbol, and valency of some of the free radicals. We shall simply refer to them as radicals. So what are free radicals? A free radical is a group of atoms that exist and react as a single unit with a charge. Take a keen look at the radicals again. Remember that you need to know and be able to differentiate the symbols of nitrite, nitrate, nitride. Take a keen look at the suffixes ITE, ATE, and IDE. Then also differentiate between sulfate, sulfite, and sulfide. Now we are ready to write chemical formulas. I shall classify chemical formulas according to valencies into three categories for ease of writing them. Category 1 shall be compounds with predictable valencies, for example, sodium chloride and magnesium oxide. Category 2, compounds with variable valencies, for example, iron 2 chloride and iron 3 chloride. And category 3, compounds containing free radicals, for example, calcium hydroxide and aluminium sulfates. So we shall begin with the first group, that is compounds with predictable valencies. But why are we calling them compounds with predictable valencies? To predict a valency, we use the periodic table. For example, magnesium is in group 2. It therefore means it can lose 2 electrons, hence a valency of 2. Chlorine is in group 7. It can gain 1 electron, hence it has a valency of 1. Therefore, we shall go straight to our first example, which is write the chemical formula of magnesium chloride. So to write it, we follow the following steps. 1. Write the correct symbol of the ion in the same order as the ion name, just as shown below. Then, write each element with its valency. From there, interchange each valency from the superscript of one of the elements to the subscript of the next element, following the arrows as shown in this slide. From there, combine the elements. After combining the elements, then simplify their ratios. After simplifying their ratios, in this case, 1 and 2 are simple ratios, therefore we cannot simplify them further. But we will notice that magnesium has 1, meaning that the magnesium is a single atom. Therefore, it does not make sense to write that 1. Instead, we just simply write the symbol of magnesium to show that it is only 1. Therefore, it is better to write the symbol of magnesium to represent 1 atom than to repeat it. And that is why we omit 1 in our final formula, which is written in red. Example: write the chemical formula of sodium oxide. Again, write the correct symbol of the ion in the same order as the ion name, as shown. Then write the valencies correctly. From there, interchange, following the arrows correctly. Then combine the elements and you get sodium. The formula tells you that sodium has 2 atoms and oxygen has 1 atom. Instead of writing the 1, we simply write the symbol to show that it is 1, and finally our compound becomes the 1 written in red. Now we go straight to compounds with variable valencies. Most transition metals and elements in group 4, 5, and 6 have variable valencies. Their valencies are written in Roman numerals inside brackets. Example: the valence of iron in iron 3 chloride is 3, and the ion is written as shown in black on that part that is blue on the left side of your screen. Therefore, we shall begin with our first example under variable valencies. Therefore, write the chemical formula of carbon 4 oxide. Carbon 4, meaning the valency of carbon is 4. Therefore, we can begin writing the correct symbol as shown. Then, write the valencies correctly. Interchange, following the arrows. Then from there, combine the elements, and you see C subscript 2 or subscript 4. Notice that 2 and 4 can be divided by a common factor, which is 2. Therefore, simplify the subscript by dividing them by 2, and your formula becomes C1O2. But notice carbon is only 1. It does not make sense to say 1 carbon, but instead just write C to represent 1, and our final formula becomes CO2. Again, the second example, we shall be able to write the chemical formula of iron 3 chloride. Therefore, write the correct symbol of the ion in the same order as the ion name. And then the valencies correctly. After the valencies, interchange each valency. After interchanging, combine the elements, then simplify them to get iron 3 chloride. Now we are headed to practice writing compounds, chemical formula of compounds that contain free radicals. You will notice that calcium is simply a metal with a predictable valency, while hydroxide is a radical. So, we treat radicals in a different way. We bracket the radical with a charge out of the bracket. Then we continue the process just as normal. Therefore, the charges, we change them to valencies, and they are simply written as shown. Then we interchange correctly, following the guidance of the arrows, and then we simplify them. We'll simplify them and combine them. From there, calcium is only 1. Therefore, we simply write Ca, the symbol of calcium, and our final compound becomes CaOH2. Notice that in this case, because the hydroxide are 2, we leave the bracket intact as it is. Our second example becomes potassium carbonate. Again, potassium is a metal with a predictable valency, while the carbonate is a radical. So again, we bracket the radical correctly with the charge out of the bracket. We write the valency, then we interchange as usual. From there, we simplify the ratios, but notice in this case that the carbonate is only 1. So we do not interfere with what is inside the bracket, we leave it as it is. But we remove the brackets and the 1. We remove the brackets and the 1 because the carbonate is only 1. Therefore, our final formula becomes as shown on this very page. From there, we shall have a third example, and these compounds that contain free radicals, and that is aluminium sulfate. Again, aluminium is a metal. It is found in group 3, while sulfate is a radical. So bracket the radical with the charge out of the bracket as shown. Write the valencies. Then from there interchange following the guidance of the arrow, and then simplify the ratios. But in this case, 2 and 3 are in their simplest forms, so we leave them as they are and retain the bracket as it is. In our third example, we find ammonium sulfate. Ammonium is a radical and sulfate is also a radical. Therefore, bracket each radical separately with charge out of the bracket as shown. And then go on to write the valencies, interchange. After interchanging, you will notice that sulfate is only one radical, while ammonia is made up of 2. So remove the brackets surrounding the sulfate ion, including the 1 itself. Therefore, your final formula becomes ammonium sulfate as shown. From there, we can be able to say you at least have some knowledge on how to write correct chemical formulas. Assignment. Write the chemical formula of the following compounds. A. Potassium chloride. B. Ammonium chloride. C. Copper 2 sulfate. D. Calcium nitrate. And E. Sodium sulfite. The solutions are Thank you. This presentation was brought to you by Vincent of the Chem School. Thank you and have a very good day.